Good afternoon, everyone. Good afternoon, my people. Welcome back to our platform. Today, I'm going to teach mathematics for junior secondary school. And today, I'm going to concentrate on one of the questions in my textbook, Teach Yourself Junior Mathematics. And the question is on page 8. Page 9, the topic is fractions. Fractions is a topic you also find in junior mathematics. I've written the question on the board. I'm going to take my time to solve this particular problem using our knowledge of board mass. Board mass. Either you call it board mass or you call it board MSA. The word board mass is just a symbol we apply, or a rule or principle we apply in solving fractions. B there is bracket. O is order. Order is made up of power, exponent, and index or indices. YD is division. YM is multiplication. A is addition. YS is subtraction. If you look at what I did, I changed AS to what? SA. Because when it comes to this kind of problem, there is nothing wrong between A and X. Any of them can come first. You can subtract first and later add. Or you can add and later subtract. For instance, in a question I did before I get into the solution, 3 minus 2 plus 1 shows that minus is coming first. And the second one is what? Plus. Some may want to solve this. They would want to add without considering that this minus is for 2. Some of them will say 2 plus 1, 3. 3 minus 3, 0. And that is wrong. So because they have said it's board mass, addition, subtraction, some of these students, they look at it that I must add first before I subtract. Not knowing that this minus sign is for 2. This plus is for 1. This here, there is a plus here, which is for what? 3. So you can subtract and later add. That's what you can see here. XA. Subtract, add. Or you add, you subtract. Anyone can come first. So if you go this way, 3 minus 2 will be 1. 1 plus 1, answer will be 2. If you don't like it like that, you can say 3 minus 2 plus 1. You can go this way. 3 plus 1 minus 2. 4 minus 2, answer will be what? 2. If you don't like it that way, you can say 3 minus 2 plus 1. If you want to say, let me add first, you must put your bracket here. Not after minus. So that when you put your bracket at that point, it will be you owe 2 and you have 1. I'll be left with 1. And the result becomes 2. That is how to apply this board mass properly. You can add, later subtract, or you subtract and you add. Any of the two can come. Looking at what I've just shown you on the board clearly, you will agree with me, board mass can apply in that way. Looking at the main question that I'm talking about, board mass division will come first before you talk about plus. So you can see that the question there is 3 over 8 times 1 over 4. Divide by 3 over 4 plus 1 over 5. So you sort out the division and multiplication first before you decide to add. And that's what I'm going to do now in the solution to this question. So I'm going to clean that and move on to solving the question. Having understood that is board mass, without wasting much of our time, this is 3, solution to this problem, 3 over 8 times 1 over 4. We change division to multiplication. In changing division to multiplication, it is the fraction that is close to that division that we're going to turn upside down. That means we'll turn it to times, the 4 will go up, and the 3 will come down. Our 1 over 5 still remains instant. For instance, this 4 on top will divide this 4, gone. This 3 down will divide the 3 up. And we're left with 1 over 8 on this left-hand side of the plus sign, plus 1 over 5. From this, we will now find the LCM. The LCM of 8 and 5 is 40. 8 in 40. How many 8 can we get in 40? That is 5 times. 5 times this numerator will give us 5. Plus 5 in 40 is 8. 8 times this numerator is 8. And the result will be 13 over what? 40. That is how to handle fraction. Don't forget about the principle, board maths, that any of these two can come first. Addition, subtraction, subtraction, addition. Remember, O is order. Order. O-R-D-E-R. Order. Not of. Is order. And that order simply means exponent, power, index. If you have question, you can put it in the comment box. You can also call us on 080 333 51748 for more questions. You can talk to the author of Teach Yourself Junior Mathematics. God bless you. Until we see you next time, remain blessed. Good day, everyone. This is author St. Vincent, the author of Mathematics, Accounting, and Finance. I'm here to take mathematics for senior secondary and the equivalent. Today, I'm going into my textbook, Teach Yourself Mathematics. Teach Yourself Mathematics. I'm moving to chapter 4 of my textbook, which is on the topic called number basis. And on page 30, I have taken some of these questions, and I'm going to do justice to them so that I will throw more light on this topic, so that when you have the pleasure of having a copy of the book, you can read more and ask questions where the need arises. Without wasting much of our time, you're welcome. The first question, this is number basis. How to write in different bases. As far as number base is concerned, we convert from any base to base 10. Base 10 is the common or basic base. You either move from 10 to other bases, or you move from other bases to base 10. That means we can move from base 12 to base 10. We can move from base 10 to base 13, base 15, base 16, and so on. So, but this first one is conversion. Converting from any base. This is base 2, converting to base 10. Another name for base 10 is denary. Another name again for base 10 is converting to decimal. Even the currency we'll talk about all over the world is in base 10. So we move from any other base to base 10, or from base 10 to any other base. If we are moving from any base to base 10, we'll talk about multiplication, addition, multiplication, addition, and raising the thing to power. Without wasting much of our time, solution to this particular problem. The first one, you will agree with me that the first question will go this way. Solution. 101.011 in base 2. Converting all this from base 2 to 10. The first 3 digits, 101, is a whole number. And the last 3 digits are decimal. So this is how we start. We say the first digit times the base we are on, plus the second digit times the base we are operating, plus 1 times the base we are operating. If you look at what I have done, 101 is a whole number. With that 101, if you look at what I did here, these are 3 digits, 101. When I take the first digit, I'm left with 2 digits, that's raised to power 2. When I take the second one, I'm remaining with 1 digit, that's raised to power 1. When I took the last one, no more digit is left as far as whole number is concerned. That will be raised to power 0. If you so, we just take your time. The whole number, 1 times 2 plus 0 times 2 plus 1 times 2. The last multiplication, the base, raise the base to power 0, raise this to power 1, raise it to power 2. After that, the next number after the point will go this way, plus 0 times 2. If you look at the arrangement, it's in the same order, 2, 1, 0. After 0, the next thing should be minus 1, plus 1 times 2 raised to power minus 2, plus 1 times 2 raised to power minus 3. That's how it will be. You discover that the way I handle it, you will discover that the problem is raised to power 1, raised to power 2, raised to power 3. And with this, you can sort out the problem. Without wasting much of our time, we have 2 raised to power 2 is 4. 4 times 1 is 4. Plus 0 times any number is 0. Plus 2 raised to power 0 is 1. 1 times 1 is 1. Plus 0 times anything here is 0. Plus 2 raised to power minus 2. Law of indices will make it 1 over 4. Plus 2 raised to power minus 3. Law of indices 1 over 2 raised to power 3, which is what? 8. Without wasting much of our time, this is 4 plus 1, that is 5. Plus 1 over 4 is 0.25. Your calculator can do that. Plus 0.125. From all indication, we add everything together. We'll have 0.25, that will be 375. So answer will be 5.375, all in base 10. That is how to handle question number 1. Converting from any base to base 10. The principle remains the same. Even if that my base 2 was in base 5, and I'm asked to convert to base 10, those 2 will just change to 5 and not the rest of it. If it is from base 8 to 10, the process remains the same. As far as you are asked to convert to base 10 from any base, the process remains the way I have done it on the board. Moving on to question number 2. Question 2, which is 1, 2, 3 in base x equal to 2, 7. 2, 7, whether I write 10 or not, is already in base 10. Whether there is TN or there is nothing, it means it's in base 10. But assuming this 2, 7 was in another base like 9, all I will do is to convert both sides to base 10. But in this case, if you convert 27 in base 10 to base 10, it's still 27. So you don't need to bother converting that. The same process, 1 times x plus 2 times x plus 3 times x raised to power 0, raised to power 1, raised to power 2, all equal to 7. Here is x squared plus 2x plus 3 equal to 27. What that one simply means is that here x squared is x squared. X squared times 1 is x squared. 2 times x is 2x. 3 times 1 is 3. So we have here x squared plus 2x plus 3 minus 27 all equal to 0. X squared plus 2x minus 24 all equal to 0. This is now quadratic equation. And when conversion has led to quadratic equation, you need to apply the formula or the methods required in solving quadratic equation. We can solve using factorization method. We can solve using quadratic formula. There's nothing like almighty formula. Mathematics says it's quadratic formula. It's not almighty. It's only God that remains almighty. So we solve using factorization method, quadratic formula, completing the square, and graphical method. But now I'm going to use a factorization approach. And that factorization approach, I'm going to factorize. If you look at the board, you will see minus 24. Minus 24 is the constant there. That minus 24 does not have x attached to it. So it's a constant. Allow that constant to multiply everything about x squared. It will give us minus 24x squared. So that minus 24x squared, you will think of, for instance, is minus 24x squared, which we'll call the product. This product, you will think of two factors that you multiply together to give you 24. And these two factors, when you add them or find their difference, it will give you the number at the middle, which is 2. So I can think of 6 times 4 as 24. And 6 minus 4 as what? 2. Then x squared is x and what? X. And then factors of minus is minus, plus, or plus, minus. So I need more of plus at the middle. So this bigger one will take a plus. This smaller one will take what? A minus. So these two factors, when you multiply them together, we'll get this. When you add these two together, you have the one at the middle. Then I can start factorization. Without wasting much for a very good time, we'll go this way and quickly run x squared plus, instead of these two x, we'll replace it with the factors, which is 4x minus 24, all equal to 0. We take them in twos. The first two, what is common is x. x plus 6 minus 4 into x plus 6, all equal to 0. If you have done a good job, x plus 6 and that one, x plus 6, must be the same. So that x plus 6 is a common factor. Bring it out. Use it to divide itself. You are left with x. Divide itself, you are left with minus 4, all equal to 0. x plus 6 equal to 0, or in a simple language, x plus 6 equal to 0, or x minus 4 equal to 0. Therefore, x is minus 6, or what? 4. But remember, we are not solving quadratic equation from the beginning. Our number base led to quadratic equation. And base can never be negative. Base will always be a positive whole number. That is what our number base is all about. So these two values, I have a minus, I have a plus. Therefore, I will now choose x equal to 4. So that means that x is in base 4. Without wasting much of our very good time, I haven't seen how to convert how to convert from any base to base 10, and how to see conversions that lead to quadratic equation from that number 2. Number 3, we are going to finally see how to add in different bases. If you look at the board, here is 2, 2, 2, 2, and I'm adding in base 4. Because I'm carrying my addition in base 4, none of my answers will be up to 4. If there's anyone up to 4, I must divide by 4 and always write down remainder. For instance, 2 plus 2 is 4. 4 plus 3 is 7. I can't write 7. I will say, how many 4 can I find in 7? 1 time, remainder 3. Always write down the remainder. Remember, this is 2 plus 2, which is 4. Plus this is 7. 4 and 7 is 1. Remainder 3. I'm carrying the 1 to the next level. 3, 6, and then 9. 4 in 9 will be twice. Remainder 1. Carry 2. Here will be 4, 5, 8. So 4 in 8 is 2. Remainder 0. I write down the 2, 0. And then carry 2. I'm writing this 2 because the 2 is not up to 4. And that becomes the final answer to that particular question. If you look at it, take your time and look at it very well, you will agree with me that that is the solution to the problems on that board. This is mathematics for senior secondary. Those preparing for this kind of exam should take note. On that note, if you have a question, please put it in the comment section, or you can call me on 080 333 51 748. For online coaching, for any extra, for questions, you want to get copies of my textbook, Teach Yourself Mathematics. God bless you. See you next time. Welcome back to my channel. This is author St. Vin, the author of Pure and Applied Mathematics. This is a Teach Yourself Advanced Mathematics. I'm going to be taking some questions on functions, composite functions, and I'm going to take something on matrices, and I'm going to solve that problem. If you need copies of the book, you can talk about it. On that note, the first one is function. That is getting the image of x. Without wasting much of our time, question 1 can be solved this way. Always equate the original problem with the one you're asked to look for. That is the 1a. We're equating it with f of what? 1. This is a function. It could be f, it could be g, it could be h, f of s, g of x, h of x, and so on. So all you do, the f will take off, then you equate x plus 2 equal to 1. In order to define the true value of x, our x here is minus what? 3. Haven't defined this value x, will plug it or substitute it in the original problem. The original problem is x plus 2 all equal to 2x squared plus 7x minus 5. Whenever I see x, I'm going to substitute with minus 3. So f into minus 3 plus 2 all equal to 2 into minus 3 squared plus 7 into minus 3 minus what? 5. The result of this is f of minus 1, which is what we're asked to look for. This result must come out. And without wasting much of our time, this is 9 minus 3 squared is 9. 9 times that is 18 plus this is automatically going to give us, this will automatically give us minus 21 minus 5, and the result here from all indication will give us minus 8, and that's the result, because this is 18 minus 21 minus 5 will give us minus 8. So you can see that 18 plus 8 will give us 26. So in a simple language, that is the result for that one. For the second one, trying to put it on this corner, the B part of the problem, you also equate the original problem with what you are asked to look for. The f will go away, and x plus 2 equal to 2. Here, x is what? 0. Having defined that, you now go back to the original problem, which is 2x raised to power 2 plus 7x minus 5. Whenever I see x, I'll put 0. 0 plus 2, here will be 2 into 0, all square, plus 7, minus 5. From all indication, here is f of 2, the image of 2. If you look at it, the result will be what? Minus 5. And that happens to be the solution to question number 1 on functions. How to handle functions. This topic, you find it in further maths, you find it in JAM mathematics, you find it also in undergraduate and student in tertiary institutions that are in line with this kind of topic. So that is how to solve question number 1. If you have any question, please do drop your questions in the comment section. You can call me on 080-333-51748. God bless you as you do that. We'll move straight to question 2. Question number 2. trying to solve question 2 without wasting much of our time. If you look at question 2 was talking about matrices. Look at it. Question 2 is 2x, 3, 5. If you look at what is on the board, 2x is the row, 3, 5 is the second row, 2, 3 is the column, x, 5 is column. So if you look at what is on the board, we have 2 rows and 2 columns. That's a square matrix. But you can see that 2 straight lines were drawn in between. That 2 straight lines simply means that this particular matrix, the determinant of this particular matrix is equal to 13. And for you to find determinant, we have what to call this 2, 5 is the major diagonal. And while this 3, 5, 3x is the minor diagonal. So the product of the major diagonal minus the product of the minor diagonal will give us this. So that means to say that determinant of any matrix is always calculated as major diagonal, product of the major diagonal minus the minor diagonal. In a simple language, the difference between the product of the major diagonal and the minor diagonal will give us determinant. So in a simple language, this 10 minus 3s all equal to 13. Collection of like terms. Minus 3s equal to 13 minus 10 minus 3s equal to 3. Our x is 3 over minus 3 and x is equal to minus 1. So that simply means the value of x in that matrices is what? Minus 1. On that note, you can see clearly this is Teach Yourself Advanced Mathematics. Teach Yourself Advanced Mathematics, which I can say is further maths for SS1, SS2, SS3. Those doing JAM and those students in the tertiary institution. You can get a copy. There is it. So call me if there is any question or if you want a tutorial on this subject, mathematics at any level, call me. We'll be able to schedule whether applied mathematics or pure mathematics. On that note, God bless you. See you next time. I remain Otto St. Faith. Good afternoon, everyone. You're welcome to my platform. Today on financial accounting, the topic we're looking at is a sales journal. Sales journal is one of the subsidiary books. I still remain Otto St. Vin, the author of mathematics, accounting, finance textbooks. Sales journal is a book that records all goods sold on credit. You can call it sales day book, you can call it sales book, you can call it sold journal, you can call it sold day book. All these names are all the same. It shows that there are times you will want to sell to people on credit. That means you are selling to them and you are not collecting money at the time of sales. You are leaving them, giving them some grace to pay later. For you to keep records, you need to prepare what we call sales journal to record all these goods you sold on credit to numerous customers. You are the one selling. It shows you are a seller. You are a creditor. The person you are selling to is a customer or a debtor, as the case may be. When you sell, you are giving out. Your account will be credited, which is the sales account. And the person you are selling to is receiving. His account will be what? Debited. That is the principle of double entry, propounded by Lucas Pacioli in 15th century. Without wasting much of our time, like I said, sales journal is not an account. It's a book. It's like a diary where you record transactions concerning goods sold on credit. I tried to draw something here. This will be our dates. This will be particulars, folio, the details and the total. It's a book. It's like a diary. It does not have, some will say, names and particulars. There's nothing wrong. Here is folio. Here is details. Details. There's a naira symbol here. Here is the total. There's a naira symbol here. So all I need to do here is to write the owner of the account. I'll write Sandy. Sandy Sales Journal. Sandy Sales Journal. Now that means that Sandy is the seller. Sandy is the one selling to numerous customers. On November 12th, Sandy, the seller, sold to John. That means that John is receiving. All we just need to do is to write the date, November 12th. We'll write John. We'll write John. The things that were actually sold to John will be copied in at, bottles of 7-Up at 10 naira each. 8 times 10 will be 80. But because there is no other one to add here, I just go straight and put it here, 80 naira, no kobo. I close that transaction. It shows that on November 12th, Sandy, the seller, sold to John goods worth 80 naira. And John has promised to pay later because it was sold on credit. If there are more transactions, I would have added. There can be 3 or 4 transactions, 4 transactions in that was sold to goods that was sold to John. On November 20, this same Sandy, the seller, the owner of this account, the supplier, decided to sell again to another person called Olaniyi. Olaniyi is a customer, is a debtor. In this case, what are the things that was sold? 4 bottles. 4 bottles of Maltese at 20 naira each. You multiply 20 times 4. That will also be 80. I put the 80 here because the question has made us to understand that there is a trade discount. So I'm going to less the discount. Trade discount, 10%. Trade discounts. 10% of 80 naira is 8 naira. You subtract, transfer the money to this side, that should be 72 naira, no kobo. You close the transaction like this and add up everything. That will be 152, no kobo. You close it by drawing 2 lines. You close this side. Let's believe that November, at the end of November, let's say 30, that all the goods that were sold on credit is sales account. And it should be credited because Sandy is the one supplying. Sandy is giving out. The double entry means that we're going to credit it. We're going to debit John. We're going to debit Olaniyi. From what you can see on the board, that is how to prepare sales journal. Sales journal. If you look at the question very well, Sandy is the person that sold the goods. Sandy is the seller. Sandy is the supplier. Sandy is the creditor. Sandy on November 12th decided to sell goods to John. John is the customer. John is a debtor because he's owing, promising to pay at a later date. John is also a customer because he patronizes Sandy on that particular day. On November 12th, we write John, 8 bottles of 7-Up at 10 naira each. 8 times 10 is 80. We'll put the value there. On November 20, this same Sandy, the seller, decided to sell to Olaniyi. And what are the things that was sold? 4 bottles of Maltese at 20 naira each. 20 times 4 is 80. And 10% because discount was given for that credit facility. Discount was given to that person. And 10% of 80 naira, 10 over 100 times 80. Or you press your calculator, you have 8 naira. When somebody gives you discount, it's a reduction in cost price. Take away 8 naira from 80, we'll be having 72. That means in the month of November, all the goods that Sandy sold on credit amounts to 80 plus 72, giving us 152. So all the goods, so that's the total sales. Remember, sales is made up of 3 types of transaction. Goods sold on credits, goods sold by cash, goods sold by check. So all these are all sales. Whether it's on credit, whether it's on cash, whether it's on check, by check, they're all sales. So this is what we call sales journal. The question did not stop there. It's a post to the ledger and extract a trial balance. Post to the ledger and extract a trial balance. So that's simple application of double entry. If you look at what I've just told you, we sold to John. John is receiving. John account will be debited. This is our debit side. This is our credit side. So, because we sold to John, John is receiving, we write November 12. I'll write sales because it's from sales journal. And the amount is 80 naira. We'll close the matter like this. The next one is Olani. Olani account. We'll have credit side. We'll have debit side. November 20. We sold to Olani. Olani is receiving. We write sales. The show is from sales journal. And the amount is 72 naira. We'll close the matter. And there is it. And after that, the next thing is the sales account. This sales account belongs to Sandy. And that means that Sandy is receiving, Sandy is giving out. And for every debit entry here, we'll have November 30. We'll write the word sundry. Sundry means various credit transaction amounting to 152 naira, no kobo. Remember, John account, Olani account, John account, Olani account, sales account represent the ledger. And after posting to the ledger according to the question here, it says you should extract a trial balance. Trial balance, like you know, is a list of all ledger balances. If the ledger is debited, the trial balance remains debited. So this is a Sandy trial balance. Just to check for arithmetical accuracy. So here is the names of account, not particulars, that's an old story. Names of accounts. And here is folio. Here is our debits. Here is our credits. If the ledger is debited, the trial balance will also be debited. John is debited. Olani is debited, 72. Sales is credited, 152, because sales is income. Incomes are always credited. It has a credit balance. On the same line on your book, you have 152. Ladies and gentlemen, that is all we can take for financial accounting. Today, we'll be able to deal with sales journal. If you have any question, you can call the author of Mathematics, Accounting, and Finance textbook for more questions. Put your questions in the comment section. Call for tutorial on financial account, cost account, and other related subjects like mathematics and so on. God bless you. On that note, we'll continue next time. Good day, my people, my good audience. Thank you for being there. I'm looking at finance, the subject for undergraduate and postgraduate students in the tertiary institution. Today we are going to look at present value of money, trying to extract the formula For present value of money, we are talking about money today. There is a future value and there is a present value. This is our formula. Future value of money is equal to the present value of money, 1 plus r raised to power n. That is the formula. For us to calculate the present value of money, we do what they call changing subject of formula by saying FV all over 1 plus r raised to power n equal to PV. In a simple language, for you to find present value of money, you discount the future value of money by putting 1 plus r raised to power n. Remember, r is the interest rate, the growth rate. FV is the future value of money, and so on. So in a simple language, present value of money is future value of money, 1 plus r raised to power n, also known as FV, future value of money, into 1 plus r raised to power n, trying to apply laws of indices there. So, having seen that, examination question could be, is that you should find the present value of money, compounding yearly or per annum. This is the formula that will go. Present value will be equal to future value all over 1 plus r raised to the power of n. When you're asked to find the present value of money, compounding, that's multiplying. Compounding yearly or per annum, this is the formula to use. FV is the future value, while this is ordinary one whole number. R is interest rate. The R can be, they can write I. Some may also write K. They all mean the same thing. R is the rate of interest or interest rate or the growth rate of the investment. And this is raised to the power of what? N. N here is the number of years, which is the duration. That is how to calculate present value of money, compounding yearly. Moving on to the second part, you could be asked to find the present value of money, the present value, compounding daily, compounding daily, weekly, monthly, quarterly, semi-annually, and so on. Our formula will just change a little. PV will be FV, but that R will be divided by M, all raised to the power of NM. That M represents daily, weekly, monthly, quarterly, semi-annually. That means if I'm asked to compound this thing daily means 365 days make a year. So that my M will be 365. Our N still represent number of years which we must have been given. If you are talking about weekly, 52 weeks make a year. If they say it's fortnightly or every 2 weeks, the M will be 26. If they say it's monthly, it's 12 months in a year. That is for real calendar month, not lunar. So here will be 12. If they say quarterly, 4 quarters make a year. So that means my M in that case, if I'm referring to quarterly, will be 4. And if it is semi-annually, that is twice a year. That means the interest will be paid twice a year. So my M will be 2. And that is how to solve the question. Finally, if I'm asked to find the present value of money, compounding continuously continuously. In that case, if you could recall that when we are doing future value of money, we did it like this, e raised to power rn, like this. So for this one, our present value of money will be equal to future value all over e raised to power rn, which can be rewritten as fv into e raised to power minus rn. All these are all what the same. You can use this. This is okay. This is also good. So that's how to, calculate present value of money, just like we did in the past. If you check out my past lectures, you will discover that we have done future value of money. We have calculated future value of money. We have calculated growth rate, which is R. We have calculated the duration, which is N. But this is the concluding part for future value of money and present value of money. So we have calculated future value before. We have calculated rate. We have calculated number of years. But here we have shown you how to calculate present value of money, either compounding yearly or per annum, compounding daily, weekly, and so on. There's a formula, or compounding continuously. Remember, the E here is the exponent, which has a fixed formula, which is 2 point something there. If you check your calculator, you will see e raised to power x and be able to get that constant formula. On that note, when I come your way again, we'll continue with more on mathematics of finance and other aspects of finance. On that note, when you have questions, please put it in the comment section. And when you need extra lecture on finance, call me on 0080 333 51748. And I will tell the details for you to have personalized online coaching with the author of Pure and Applied Mathematics. God bless you. See you next time.